Hello viewers, Alan here. Welcome back to the workshop. In this video, which I might have called Perseverance Pays Off, I want to show you how I worked through finding a solution to a problem. The problem was that, first up, what is this? This is a NITO or NITO style compressed air outlet socket, and there's a rubber seal in the bottom there. And in my home brewed air distribution system in the workshop, there's probably about 20 of these things, and I reckon one or two of them have got a very slow leak. So slow that I can't find it even with soap and water. It needs a maintained test, a test that's held in place for maybe even half a day or 24 hours. In any case, some of these things are under benches and difficult to get at places. So I wanted to make something which I could plug into this and leave it in place, and then come back after a day or whatever and see whether or not there was a slow leak in place. So I did in fact come up with something. It's something which plugs in and has a pressure gauge on the end. The passage to producing that wasn't smooth though, and this was actually the fourth iteration of a design to get the job done. But anyway, I thought it'd be interesting to share that process with you. So if you're interested, let's get started and see how it all worked out. So my plan is to reuse this. This is a piece that I made up to do pressure testing on the Lynx engine. Anyway, so I've got a way of getting hold of it. That's 7/16 UNF for some reason, 7/16 20. So I've already drilled the other end of this and put a 7/16 20 in that. So that'll take care of that end. So what we need is to deal with this end so that it will plug into that. And of course that'll be familiar to many of you. So I need to put that sort of shape on the end of that with an added twist. I want to put I don't want to have this tapered piece on the end which pushes the thing open at the back there. So I won't have that bit, and what I will have though is an O-ring groove there. The idea being that when my piece is put in there, the O-ring will seal around the outer edge there. And I've just seen a fatal flaw in that. The ball bearing holes are on the wrong side of that O-ring. Rethink needed. Okay, after a rethink, I think the solution is pretty simple. There's actually enough room. I'm not sure how well you'll be able to see down in there, but there is actually enough room underneath the ball, the three balls, and the bottom of the hole. I can get an O-ring groove there, and that will avoid the issue of air sneaking out through the ball bearing ball holes. So that's what we'll be doing. Slight revision to the plan. We'll sneak up on this. I might try it at 11 first and see how that looks. Well, that should be extreme because that's 11.2. Oh no. Actually, that's probably, that's got to be worth trying at that. Okay. Oh. Hello, what's going on now? I guess the balls were getting hung up on the thing. Probably not a good sign for longevity. Yeah, it's like it's chewed the O-ring up there. No idea whether you can see that, but anyway, it has chewed pieces out. So I need to try to understand what's caused that. Okay, I think I've worked out what's going on, and not good news. The way I've got it set up, the O-ring is pressed against the wall of the hole by virtue of the fact that the groove isn't quite deep enough, and that's what I was wanting to do. But when these balls are pressed back, well, you can see that they create a round hole there with a sharp edge, which is like a cheese grater, which rips lumps out of the O-ring on the way back. I think it's really back to the drawing board this time. So with my third design, I'm aiming for something that looks a bit like that. Tap washer will be familiar probably to many of you. So my interpretation of that for this job, there's the female socket fully disassembled. And that's the piece I've already made to go in there and trap the ball bearings, so that's that bit. I haven't yet put a hole through that, but it will have a hole through it. And this piece will come through the hole and press a rubber washer against that shoulder. You can hopefully see at the bottom there. And to hold this in place, I'm making this bolt here. So you can see that I've, perhaps you can recognise there's a bolt. I've drilled right through it with a 1/4 inch, and the bolt's now sitting on a 1/4 inch mandrel because I want to machine off the threads of the last 9 or 10 millimeters. And then I'll be drilling a hole, cut this to length and drill a hole through it, tap it for M10, and hopefully it'll all come together. So what I want to do here is cut that groove which the balls engage in this piece, and I'm going to do it in a 3-part operation. I'll plunge in for the centre using this 2mm wide blade, and then do a pass from either side at an angle, and hopefully produce something that looks a bit like that. So moving on, I've got the bottom of the grooves sorted and that side sorted, but I want to do the taper on this face now. To explain the setup, I've got the top side tilted or canted at 60 degrees, and to measure the depth of cut, I've got a dial gauge on the back of the tool block. Obviously I can't just use the gauge here for the depth of cut I want because it's a different distance. I could work out what the length of the hypotenuse is, but it's just easier to use the dial gauge and go in 1.15 millimeters. And that should be that. I can do a trial fit with the ball bearings now and see if they line up with the groove. Yep, so that's pretty good. Right, just check it with one of the automatic ones as well. These guys are a little bit different. You don't hold the ring to push it on, you just pull the ring back to get it off, but they've got some other arrangement in there, a shroud that covers the balls. Anyway, see how we go. Oh, yep. So I'll be parting this piece off just pretty much on that the line created by that flat, which will mean this piece is about 15 long. So I'm going to drill in about 20. Give myself a bit of wiggle room. Now I'm going to open this hole out from 8mm to 8.5 of the boring bar, because all of my drills seem to drill oversized. So that was an 8mm drill, and it's the hole is 8.25, which is somewhat bigger than I would like. So, boring bar it is. So I got my 8.5, but yeah, it's probably just slightly tighter than I wanted. I don't know. There's probably nothing there that a bit of emery paper wouldn't sort out. That's pretty good, I'm happy with that. So, just for interest, what does this thing say I'll finish up with? Right, 8.5. Alright, let's get this guy parted off. I reckon that came out alright. So all I've got to do now is put the M10 thread in from the back side here. We'll start cutting this M10 thread here, but I don't think there'll be enough grip in the chuck to hold it, so basically as soon as it starts to slip a little bit we'll be over to the vise so we can grab hold of it with the flats. How far we'll get. And it's just started to turn, but the tap's already off to a good start, so that's fine. We go and put it in the vise and grip it by those flats, and by gripping it in the drill vise on the bench drill I get the best of both worlds. So I finished the turning those or cutting those threads, as you can see, and my bolt now goes in quite nicely. In the process of doing that though, I realised in those trial assembly, I realised that the bolt was actually a bit shorter than I would like, and decided to make another one with a slightly longer machined nose. Just gave me a bit more flexibility with more of the bolt sticking out this way. The next thing was to have a look at the piece that presses on the rubber washer, and I decided that no, it doesn't want to go in easily because I practiced cutting these grooves on it. Anyway, I decided that was too short, so I made a new one of those, and I'm quite happy with that. I made it with a thicker head because I was originally thinking about putting 2 holes in the face to drive it with it or hold it with a pin spanner, so that when I put an adapter on this end, this is a 1/4 32 thread, and it's to allow a pressure gauge to be connected. Anyway, so that will fit through there. I've, as I said, cut that thread, and this is a bung, a stopper, 1/4 BSP. I drilled that out and tapped it to match that thread, and put the 2 flats on here so I can hold that when I'm doing that up, and I'll mount a pressure gauge on there. This whole lot now does fit quite nicely in there, as you can see, and I've made a seal washer to go sit on that seat that you can see at the bottom there. Maybe not terribly well, but anyway, there's a seat down there. So this is 3mm neoprene, and I just used a 1/2 inch punch to cut a disc out, and tried to put a hole through the middle of it. Well, yeah, there's a hole through it, but anyway, that will fit in there. And that face will press that back against its seat. Like so. Oh, haven't got the no, back that out a little bit, like that. So that's how all that lot works, and then I can hold that, tighten that up to put a bit of pressure, a bit of compression on that seal. So all that's left to do, I think now, so I can test it, is to properly install the pressure gauge with some thread sealant, and then we'll see how it works. So this is the test setup. I've taken the seal ring out of the internal seal ring of this so that it's equivalent of 100% leak. This adapter here is just to allow me to connect my compressed air supply to it. Yeah, so that's the bit that normally sits in the bottom of that. I've got the compressor, the air pressure turned down quite low. It's about 20 psi. So you can see that's holding steady and I'm not hearing anything. I think it's worth pointing out as well that I don't actually mind if I do get a bit of leakage here, provided the seal works well enough to hold pressure on the gauge. If there is in fact any air leaking past the seal, then the gauge will register, and that's all I need to know, that the socket is in fact leaking. Right, well, my real world test failed abysmally. It turns out that piece that you can see at the bottom there it's the activator bar that presses on that's pressed by the end of this Nitto plug. To my eye, the top surface of that activator bar was below the bottom edge of the surface I was using for my seal, and I think it is, but the problem is when the seal is pressed down, it presses actually against that hard enough to open the port. So it's a completely useless method. So that's the third failure. However, I think I've now got a solution which is going to overcome all of the problems I've had. So what I'm going to try now is moving the seal from being between the bottom of this rod and the face of the socket. I'm going to move the seal to there, which will trap it between these two pieces. And then if I've got a nut on the top here pulling this up, I think that will squish the washer against the inside diameter, well clear of that thing activator at the bottom there. So let's give that a try. Hopefully this will be the winning solution. It'll certainly be simpler because I won't need so many pieces. So I've made a new one of these, a body shall we call it, and got it mounted in the collet chuck, and I want to cut a couple of spanner flats on it. But the diameter that I've got it gripped by is only about 10 millimeters long, and I'm a bit worried about it coming out of the chuck, so I've put a bolt through so it can't possibly eject itself from the collet chuck. So let's knock these spanner flats, and then I think we'll have finished all the machining. Alright, so let's see where we finished up. Shooting for 17. Just under 1703, 1702. So that'll be fine. And this 17mm spanner. Yeah, that was a bit oversized in the opening. But anyway, that'll be fine. Okay, now I've finished all the machining, I want a rubber washer to go there to get squished. Yeah, and so I've tried to do it, as you see, a few practice runs, trying to get it concentric, and I didn't think I got it good enough, because the washer I think the washer needs to sit fairly evenly around there. I did put that on and try it, and it seemed to work, but I wasn't happy. So I needed a better way of making the seal, so this is what I've worked out as a way to go. I'll do the little hole first. Right, and I've made this little button up with the diameter on the bottom that sits in the hole, and the top diameter matches the inside of the larger diameter punch. So I think that will get me pretty close. Still won't be perfect, but I think it will be a lot better than what I was achieving freehand. So let's see how we go. Not too bad. Yeah, I think that one's pretty good. I think we'll use that one. So we'll slip him on. Let's do a bit of a squish test and see how it looks. Yeah, that's squished out pretty evenly all around. pretty confident that's going to seal. So I'll do the first test the same way I did the other one, so there's no nothing in there, it's completely free to air. So I've still got the low pressure setting in place. Not hearing any leakage, so I can wind the pressure up a bit, I guess. Yeah, so pressure's going up. Let's take it up to 50 psi. I don't think there's any reason to test it at higher than that. I can't hear any hissing. When I put it into a test in the real world, if I get any pressure reading here at all, I know I've got a leak, so that's really all I need to see. Alright, well let's give it a real test. Right, so that's got the leak tester installed on the first of the sockets, and there's no immediately obvious leak, which is good, but I'll have to leave it in place, or I'm going to leave it in place for 24 hours on each of the sockets, because I'm looking for a very slow leak. There's about 20 sockets, so that's going to take a while. Okay, well I guess if you're still here, you found something interesting to watch in that. I don't mind an iterative approach to finding a design. I mean, you can start out and say I'm not going to cut metal until I've got every last detail resolved, and clearly I was a long way from that in this case, although to be fair I did actually have a detailed drawing which I produced for the first iteration, but of course because that was a complete failure it went in the bin. But some combination of pre-planning, drawing, designing, and then getting in and trying and iterating, that's what works for me. Anyway, as I say, hopefully you found something interesting in there, and in any case, thanks for watching, and I hope to see you on the next one.